Welcome back to school. Alright, so today's lesson is going to be about energy. You have the notes, and I believe when I scan the notes, they're reversed, so the sheet that's second on there is the one I'm doing today. Alright, so bear with me. Yes, the cat is back. Must not close the door. Alright, let us begin, shall we? Energy. This is not the definition, this is just my title slide. Energy is about change. Alright, so the definition of energy is the ability to cause change. Pause, write it down, then come back. Alright, there you go. Energy comes in many different forms. It can be saved and spent just like money. You don't write this down, this is just a thought that you need to keep in your mind. So energy can be saved, energy can be spent. If you don't believe me, think about last time you saw me. I had a lot of saved energy in my body. I'm fat. I can spend that and lose it if I want to. But anyways, something like that. Don't we all have to have that just laying around the house? No, we don't. I don't either. I found it on the internet. Anyways, moving on. Two main categories of energy that you need to be responsible for are kinetic energy and potential energy. Each one has a section on the note sheet, so let's begin. Kinetic energy is the energy a moving object has because it is moving. So it's moving, and because it's moving, it can cause change. Energy is the cause of change. Pause, write that down, and then come back. All right. Are you back? Good. Kinetic energy can be calculated with the following equation. Yes, there's an equation, and I am so sorry I'm not there to help you through these equations because this one's a pain. But you can do it. Kinetic energy equals 1/2 times the mass times the velocity squared. Alright? Now, let's look at that equation again. Ooh, got big. There we go. Alright. You know what M and V are, mass and velocity, measured in kilograms and meters per second. Sorry, cat's making noises. Alright, the units of energy are kilograms times meters squared over second squared, because the velocity is squared. That unit has a name, and we've called it the joule, named after some dead guy. That's why it's a capital J when you abbreviate it, because it's named after a dead guy whose name was Joule. Go figure. So from now on, the unit of energy is the joule. And in case you want to know what joule looked like, not like her, like that. James Prescott Joule. I'm having a little beard envy here, but not the hair. Alright, the other type of energy is potential energy. Yes, there we go. Potential energy, abbreviated capital P, capital E, is the energy an object has stored due to position. I know that doesn't make a whole heck of a lot of sense right now, but write it down and I'll explain it with various examples. Alright? Okie dokie, here we go. There are many different types of potential energy. Sorry, I took a little break there. So, there's many types of potential energy. First one we're going to talk about is electric potential energy. It's a long definition, so get your hands ready. Here you go. Potential energy stored in electrons that are gathered at one end of a circuit, ready to move to the other end. Write it down, pause, write it down, come back. Here we go. Okay, so a circuit is the path electricity follows to get from the negative end of a battery to the positive end. See the plus sign, right? That's the positive end. Electrons are gathered down here. So inside this battery, there's a chemical reaction happening that separates out electrons from the carbon rod going through the center. This except a little bit there. It's covered by metal, but the carbon rod is sticking up right there a little bit. Electrons gather down here. Electrons don't like each other because they're all negative, which means they repel each other. Plus, they're attracted to the positive end here where they came from. Basically, electrons want to go home. They don't understand, do they? So electrons gather here. Because of their position, they want to be somewhere else. If you give them a path to go on, like a wire going from here to there, a circuit is a path they can go on, they will go. So they have the potential to cause change due to their position, potential energy. In this case, it's electric potential energy. Find in batteries and in generators. Okay, I just realized I'm a little dark there, so there. Better or scarier? I don't know. Moving on. Chemical potential energy. Energy stored in the bonds between the atoms of many molecules. Oh yeah. Chemical potential energy. Caffeine. Those energy drinks, those monster drinks some morons drink. Oh, I'm sorry, are you one of them? Stop drinking them, they're bad for you. But basically, you get all the energy you need from your food if you eat enough of it, and the right kinds. Alright. The foods are made out of chemicals, everything's made out of chemicals, but the food is compounds that your body can break down and release energy from. So this is found in food and gasoline, and many, many other things too. There's just two common examples in your life. Third type of potential energy is elastic potential energy. Here's a definition. Energy stored by something that can stretch or compress. Pause if you need to, write it down, then come back and look at this. A rubber band. It can stretch. It can store potential energy. There we go. No, I can't hit you, right? Some of you probably went, and flinched. Seriously, it's a recording. I mean, it's Sunday. You're probably watching this. Half of you probably watching it Saturday. But still, you're supposed to watch it Monday. But you know this can cause change, because I can do like that. I should hit something. I hope that came through in the recording. Yeah. Another example would be springs, which you have on your cars and your beds, box spring in your beds, and most of your recliners, chairs, and sofas have springs in them somehow. Alright. So, this is storing energy because I moved it to a new position, and it wants to go back where it came from. Ow. Alrighty. Another type of potential energy is nuclear potential energy. Sorry I don't have an example to show you like a rubber band or anything, but nuclear potential energy is energy stored in the nucleus of an atom. We spoke about this already when we talked about fusion and fission, alpha and beta decay. Remember the good old days when we were in the classroom? Yeah. So, that's the definition of nuclear potential energy. Pause if you need to, and I'm going to move on. Oh, we use this for, well, you know what we use it for. Nuclear power plants and atomic bombs. The last type of PE, potential energy, you need to know about is, yeah, the one with an equation. Sorry. Gravitational potential energy. There's a definition. Energy stored by objects due to their position above Earth's surface. Pause to write it down, come back, and here we go. So if I take this, I drop it from here, I might hurt my laptop. If I drop it from way up here, you can't see way up there, but drop it from way here, has more of a chance to hurt my laptop. It can cause more change because it fell from higher up. Does that make sense? More of an ability to cause change because it fell from higher up. Its position higher above the ground gave it more potential to cause change. Potential energy. Alright, like I said, this one has an equation. Oh, sweet joy. And here it is. potential energy due to gravity, so gravitational potential energy, equals m times g times h. I'm going to break it down on the next slide. Another way to write gravitational potential energy is big G, big P, big E, instead of big P, big E, subscript little g. I don't care which one you use. I don't care. M times G times H. What is M? You already know this. It's mass measured in kilograms. G, if you still have your reference tables, look it up. It's on the front cover. Acceleration due to gravity, which is always on Earth, 9.8 meters per second squared. Different numbers on different planets and moons, but we don't live there. We live on Earth. So on Earth, it's 9.8 meters per second squared. Boom. Little h is the height above the surface measured in meters. Alrighty then. The unit again is the joule. If you take mass times g times height, you get kilograms times meters per second squared times meters, which is kilograms times meters squared over second squared, which we've already defined as the joule. Alrighty, well, what y'all think about this? An object is falling. What happens to its gravitational potential energy and its kinetic energy? Let me just walk you through it. As it's falling, the height gets smaller. Height's part of the GPE equation, so as it falls, it loses gravitational potential energy. But you also know when something is falling, it's accelerating, which means its velocity is getting faster. The kinetic energy equation, 1/2 times m times v squared, has velocity in it. So if the velocity is increasing, kinetic energy is increasing. In fact, and this is the point I need you to drill into your heads, as an object falls, every single joule of gravitational potential energy it loses turns into kinetic energy. Alright, need to go ahead and attempt the worksheets. I think I gave you one for today, and I gave you the answers too, so you can check over it. Don't be that idiot that just copied on the answers. Look, I did work. No, you didn't. Work them out for yourself. Check them. If you absolutely cannot understand it, send me a private message. Send me an email, send me a text in my special school number that I probably contacted your parents with already, or wait till Thursday when I do my live Google Meet from the churchyard down the road where I have free Wi-Fi. Alright, that's it for today's little lesson. Again, welcome back, and have a good day.